Okay, good morning, all of you. So, in continuation with our yesterday's lecture, today we will discuss the remaining part of ultrasonic machining. Yesterday, we have seen that working principle of ultrasonic machining is setup. We have seen, and we were discussing about the fishbone diagram of ultrasonic machining. Okay, you can call it is parametric analysis also. Okay, so let us briefly discuss this parametric analysis of ultrasonic machining. Now you can see in this diagram I have shown there are various parameters which affect the performance of the ultrasonic process, that is USM process. And I have just mentioned to you that there are various parameters, or we can call this parameter as responses also. Okay, with the help of which you can evaluate the performance of ultrasonic machining. Now which are the parameters through which we can evaluate the performance? So that parameters or characters I have shown here. You can see in the red color I have written that performance characters of USM. Okay, in that one, first is the ultrasonic the material removal rate, MRR, then tool wear rate, cutting ratio, surface finish, and form geometry. So through these responses or the characters, you can evaluate the performance of your process. And on other hand, you can see we have the different process parameters which will affect the performance. Okay, so it is called process parameters. Okay, so let us discuss one by one. Okay, now in this fishbone diagram, it shows that you have various parameters which affect the performance of ultrasonic machining process. Okay, again in that first parameter you can see if you consider this slurry. Okay, so in of this which are affect the performance of this USM process. So it includes feeding mechanism. Okay, slurry feeding mechanism, then temperature of that slurry. Okay, again or and again we have the concentration of the slurry, or we can call concentration of abrasive particles in that slurry. Okay, so under slurry we have the another parameters also. Okay, again what is the abrasive type that you are using? Okay, so type of abrasive also need to consider. Okay, then we have the volume fraction of the abrasive in that slurry, volume fraction of the slurry abrasive in that slurry, and the size of glit. Okay, size of glit size, we can call glit size, or the abrasive particle size. That also we need to consider, and normally it varies from 250 240 to 800 mesh size. Okay, glit size we can measure in the mesh size. Okay, again the viscosity of the slurry, that also important because it affects the performance. Okay, so what liquid medium you are using, that is also very important. Then another important parameter is the, you can see here. Okay, another pink colored I have shown, that is our tool. Okay, so in that again tool, whether single point tool you are using, sorry, single tool you are using or multiple tool. Okay, means more than one tool you can be used for machining at the same time. Okay, so it is called multiple tool. So whether you are using single tool for ultrasonic machining or multiple tool, that also affect the your performance. Okay, then the material of your tool. Okay, what are the damping characteristics of the material of the tool, and what is the ductility of material of the your tool? Okay, so these points also you need to consider. Okay, or both of these, that means the damping characteristics of the material of the tool, or ductility of material of the tool. So both of these will affect the performance of ultrasonic machining. And another very important parameter is the surface finish of your tool. Okay, so here I have written the finish of the tool. So as I have already mentioned that sometimes that if scratches are there or micro cracks are left on your tool surface, then it will quickly fail because of ultrasonic vibrations and the load acting over it. So due to that, it may fail. So if finish is not good, then this will be reflected to some extent on your finish of the your machine component. Okay, also definitely geometry of tool will affect the geometry of the machine cavity, because whatever the cavity we want on our workpiece, so the replica of that or inverse replica of that cavity we are giving to the uh, uh, shape to your tool. Okay, so definitely the geometry of the tool will affect the geometry of the machine cavity that you are going to get on your workpiece. Okay, so this is about the tool. Okay, first we have discussed about the slurry, then tool. Now let us discuss the next one, that is the workpiece. Okay, now under this workpiece we have the different parameters like types of material, the strength, hardness and the thickness. Okay, because what is the type of workpiece material will also affect the selection of the your process parameter. Okay, then what is the hardness of the workpiece material, that should be considered, because according to the hardness of the workpiece you have to select the type of abrasive particles. Correct, I repeat once again. uh, Depend on hardness of workpiece material, you have to select the type of abrasive particle. Okay, so hardness, that types of workpiece model that we need to consider. Okay, then again, what is the thickness of the workpiece and what is the strength of workpiece material. Okay, that will also affect the performance of the ultrasonic machining. Because of that only I have written here, you can see here arrow I have given. Okay, hardness and you can see the strength. Okay, and that thickness also, what is the thickness of workpiece, uh, what is the thickness of workpiece. Okay, and what is the strength of the workpiece material. Okay, so that I have written. So this was about the workpiece. Then the another process parameters which is related to the machine. So in that here I have written that amplitude of the vibration. So amplitude of vibration is going to affect the performance of process. Okay, how much static load is acting, that will decide with what is the velocity of particle. Okay, so that velocity of particle is going to hit the velocity means of kinetic energy, so that will hit the, your workpiece surface. Okay, then which type of transducer we are using, so it whether it is piezo type or magnetostrictive type, so that also we need to consider. Okay, again, what is the power input to the transducer, or the force with which you are hitting the abrasive particle, which will carry with the it to the your workpiece, that also we need to consider. Again, the frequency of vibration. Okay, also that affect the performance of your process. So under machine, these parameters we need to consider. Like here I have mentioned amplitude of vibration, static load, then which type of transducer you are using, whether it is piezo type or whether it is magnetostrictive, then frequency of vibration and the power input to the your transducer. So these parameters we need to consider. Okay, now let us discuss the another parameters which affect the performance of process, that is a tool holder. Okay, so you can see here tool holder. So the shape of the tool holder and the material, that also affect to some extent to the your performance of USM process. Okay, so shape and the material of your tool holder. Okay, so here you can see the I have written in the by black color. Okay, so material and the shape. Now the question arises is that what way you are going to evaluate the performance of ultrasonic machining process. Okay, what way means what, using which parameters you are going to, or with the help of which parameter, or how you are going to calculate evaluate the performance. So you can see here in this rectangle I have shown. So you can evaluate performance of process in terms of material removal rate, in short material MRR, then tool wear rate TWR, then cutting ratio. So the cutting ratio is nothing but the ratio of your material removal rate divided by tool wear rate. Okay. And obviously the surface finish. So using that you can measure the your performance. So it is called the process parameters or parametric analysis you can call, or fishbone diagram of ultrasonic machining. Okay, so this is very important for your project or for any advancement in this manufacturing or machining process. You can vary any parameter and you can see how the variation of any, for example, if you change the type of material of your workpiece, how it is going to affect the performance. That also you can see, or you can change the abrasive type also. Okay, then you can change the amplitude of vibration or the frequency. Okay, by changing this or by varying this process parameter, you can check how the performance of your process is going to change. Okay, and then you can after many experiment you can choose the optimal solution. Okay, so we should know the this. Now this diagram, actually I have drawn, this is my handwritten diagram is there. Okay, you don't sketch pen, but this diagram you will get in the that advanced machining process NPTEL course by Vijay Jain. Okay, Vijay Jain. Okay, now I will give 2 minutes to okay, I will give 3 minutes to draw this diagram because this is very important. So I request all of you, please draw this diagram. All of you, please draw this diagram. This is very important. And if you see the diagram for abrasive jet machining or water jet machining or uh, abrasive water jet machining, okay, for each and as well as this ultrasonic machining. So process parameters are different. Okay, so you should know. Hurry up. And the one instruction. Okay, only and uh, taking the review of the all subject teacher presently, only 20 to 25 students only joining the lecture. Other I don't know where they are taking lecture or okay. So my clear cut instruction that you are paying the fee call to the college and you are not attending lecture. Okay, what is use of that? That means you are wasting your time as well as the money. Okay, and the most important thing now, tomorrow you will get the attendance of the first month. That means how much lecture, how many lecture you attended for per subject. Okay, and what was your attendance in percentage, everything. Okay, those students having attendance less than 70%, okay, definitely you will get the call from the HOD sir. Okay, directly to your parent. Okay, and then there he's going to give some instructions regarding attendance and not sanctioning the term work and other things. Okay, because if your attendance is very less, definitely its effect will be there on your term work and the performance as well as the, your project also. And only 1 month is remaining. Okay, and what the students are doing at your home, at their respective home, I don't know. Okay, just time pass. Just to think you are paying the full pay to college. Okay, and if you calculate per lecture you are paying near about 60 rupees. Okay, so take a refund by attending these lectures. Only I think less than 50% students are attending lecture. Okay, Okay, so those students are not attending lecture, definitely I'm going to take action against them. Okay, directly action, that means by deducting their term. Okay, I'm not going to give more than 12 marks. Okay, and definitely the project, there is a big loss there. Okay, because project having the 200 marks. Yeah, so the students who are having the less attendance, they print only passing marks. Okay, like 25 marks we are going to give. Many times I have already given messages, instructions on WhatsApp also. Please attend the lecture seriously. Only 1 month is remaining. Okay, I think up to 15th April or maybe 20th April we have to finish all the syllabus. Okay, and it will finish no problem. So through you or you all, I'm going to give this message to those students who are not attending lecture. So please inform them also. Now we have started the making phone call to parent. Okay, though the students, those who have attendance less than 70%. Okay, and one anchor sir giving as a HOD, he is giving strictly instructions to the parent. Okay, if your students is not attending lecture, definitely his loss will be there in terms of marks and everything. Maybe the strict action will be there. Okay, like not granting the term of and other things. So please attend the lecture seriously, all lectures. Your attendance should be more than 80%. Okay, then you are at a shaper side. If less, then definitely strict actions will be there. Now you are B students. Okay, you know what is good and what is bad. And I'm not getting the point that if you are not attending this lecture, then what you are doing at your home? कोरोना होता, ओके ठीक आहे की बाबा एक थोडे दिवस, पण नंतर आता झालं की वर्ष होऊन गेलं की तरी जर सिरियस नसतील मुलं, तर काय तुमचा लॉस आहे, काय तर आमचं काय लॉस आहे. Okay, let us discuss the next point. So, just I will take the recap. So, we have already covered that what is ultrasonic, block diagram of working of ultrasonic system. Okay, then we have discussed the working principle of ultrasonic machining. Okay, then yesterday we have seen that various elements of ultrasonic machining setup. And today we have discussed this parametric or fishbone diagram of ultrasonic machining. So, let us discuss the effect of various process parameter on performance of ultrasonic machining. Okay, so let us take the first parameter, that is amplitude of vibration and penetration rate. Okay, so amplitude of vibration is one input process parameter, and we are going to see how this input process parameter affect the performance, and the performance here we have evaluated in terms of penetration rate. Okay, so this slide shows the a relationship between the amplitude of vibration of the tool and the penetration rate, that is penetration rate of the your abrasive particle into the your workpiece surface. Correct. So you can see here that the amplitude of vibration is increasing. You can see the curve. Okay, path of the curve also. So amplitude of vibration is increasing, and simultaneously the penetration rate is also increasing. But beyond certain limit or beyond certain value, this is trying to become more or less stable. You can see here after certain this value, it is trying to uh, become more and or less stable, that means linear. So the penetration rate increases up to certain limit. Okay, with respect to amplitude of vibration. But if amplitude of vibrations increase beyond this value, which is I have shown here, so the your penetration rate, it tries to stabilize. Okay, you can see. Okay, it tries to stabilize. Okay, as also you can see beyond this value. Okay, the arrow I have shown, it tries to stabilize like this. Okay, that means a straight line you will get here. Main reason of this is a constant force. Okay, since the force remaining remains the same, okay, up to that certain limit. Okay, so due to that it's try to stabilize beyond a certain value of amplitude of vibration. Okay, so this is the relationship between the amplitude of vibration and penetration rate. Here also I have written that penetration rate increases up to certain limit. If amplitude of vibration increases further or beyond this value, it tries to stabilize that penetration rate. Okay, and the main reason behind this, the your constant force. Okay, so keep in mind this point. Now let us discuss the another one relationship, that is the frequency of vibration and the penetration rate. Okay, so you can see here, as we can see here, as the frequency of vibration is increases, the penetration rate is also increases. Okay, but after a certain value it tries to stabilize. So as the frequency of vibration increases, penetration rate increases up to certain limit, and with more number of abrasive particles impacts, okay, with more number of abrasive particle impacts per unit time on your workpiece, definitely rate will increase. Okay, and beyond the maximum value it tries to stabilize, as you can see over here. Okay, after some value, the your penetration rate is going to stabilize. Okay, then another parameter is the abrasive grain size. Okay, so you can call glit size or grain size. Okay, there is another important parameter which affects the penetration rate. Okay, you can see as the glit size is increasing, there is an optimum value where you get the maximum penetration rate in terms of in unit mm per second. And here the machining rate, okay, actually the machining rate means that your penetration rate will be there, so it also increases up to an optimal value, okay, where you will getting the maximum. But beyond that maximum value it start decreasing because the force is constant, so you will get the dome like this. Okay, that means after beyond this limit the penetration rate will get decreased. Okay, because the force is constant at a different glit sizes, okay, during the experiments. So as the glit size further increases beyond the optimum value, then the penetration rate start decreasing. Okay, you can see. So this is the one important parameter. Then let us have another, that is hardness ratio. So the ratio of workpiece hardness and the tool hardness, so that also plays an important role, as we already know that the hardness of workpiece increases, the material removal rate goes down. Okay, so you can see the hardness ratio increases, the material or metal removal rate, that is MRR, it is getting down. Okay, so you can see here as the ratio of workpiece hardness and the tool hardness, it is called hardness ratio, it increases, the material removal rate in terms of mm per second it is decreasing. So it becomes more or less uh, beyond a certain value of this ratio also. Okay, and if the hardness of workpiece is very high, then material removal rate may decrease, okay, substantially, and which will tends to maybe towards the zero also sometimes. And if you hardness ratio increases, material removal rate decreases, because whatever the penetration rate is there, so that penetration rate is the function of your workpiece hardness. And if the tool hardness decreases, then abrasive can penetrate inside the tool to reduce the penetration rate in that your workpiece. Okay, so again, if the tool hardness decrease, then this your hardness ratio becomes higher. No, if you tool hardness less, then hardness ratio will be higher, but the abrasive particle will penetrate inside the tool, and this will decrease the penetration rate also. Okay, so this is about the hardness ratio. Let us discuss the another, that is particle average particle velocity. As you can see in the slide, as the particle velocity increases, the material removal rate or the machining rate, MRR, in terms of per second is increasing. Okay, that means particle velocity and machining rate is in linear relation. Okay, because we already know that penetration is a function of kinetic energy, that means the 1/2 m square. So the particle velocity is increasing, the material removal rate or machining rate is also going to increase. Okay, then we have the another process parameter, that is the abrasive concentration. So as the concentration of abrasive particle increases, it increases the material removal rate. Okay, you can see the curve, but beyond a certain concentration value, your machining rate, it start decreasing. Okay, you can see, and as abrasive concentration increases, the machining rate attains the optimum value. Okay, which is I have shown by the dotted line. And if the concentration is too high or beyond optimum value, then due to the lower impact velocity and the collision of your abrasive particles with each other, that collision, that results in terms of in reduction in your machining rate. Okay, this is average constant. Then we have the another process parameter, that is static load. Now this static load plays an important role, as we can see in this slide. Here static load is increasing. You can see static load is increasing. Then your penetration rate is also increasing. Okay, in per second. But beyond a certain value of your static load, here you can see the dotted line also, in both the cases of amplitude of vibration, because if amplitude is different, then definitely a static load is going to different. So in both cases of amplitude of vibration, the penetration rate is going to start decreasing. As amplitude of vibration increases, the penetration rate is also increases. You can see red arrow. So the relationship between your static load and the penetration rate shows the optimum value. Okay, and optimum penetration rate increases with increasing in the amplitude of vibration. So this also can be seen that optimum value is higher for higher your amplitude of vibration. Okay, now again in that, if you vary the static load as well as the tool diameter, you can see the this last at the bottom another diagram. If you vary the static load as well as by varying the tool diameter, then this kind of relationship you can or you will get. You can see, okay, as static load is increasing, penetration rate is also increasing, but beyond certain value or optimum value, as you have seen in the earlier figure also, it start decreasing. Okay, but as tool diameter is increasing, the penetration rate is decreases. Okay, you can see, and as increasing in that tool diameter decreases the penetration rate, because pressure decreases with increasing in the value of tool diameter, because we know that pressure is equal to force divided by tool cross section area. Okay, and increasing in static load increases the total force acting on the slurry or the impact force acting on each other. Okay, so static load can be increased by counter that values and other. So this was about the static load. Now let us discuss the another point, that is the process capability. So after studying the effect of different process parameters on performance of this ultrasonic machine process, let us see the capability of this particular process. Okay, so the process, if you see here, First point. So this process works better for hard and brittle your workpiece material. Okay, and the hardness normally recommended of your workpiece should be greater than or equal to Rockwell hardness on scale that is 40. So you can take HRC more than 40. Okay, so that time also this process works better. Okay, again the material which can be comfortably machined. So that material includes like carbide, ceramics, tungsten, or glass, etc. Okay, and the surface finish value, that is RA value, that can be obtained by this particular process is in the range of, here I have written the 0.25 to 0.17 micron. Okay, however, all this will depend upon the selection of the parameters of your ultrasonic machine. Okay, then accuracy. Okay, and the process capability we can measure with the help of surface finish or the work material, and the third one, the accuracy. So normally the holes that are obtained from this ultrasonic machining process have the conic shape. Okay, that is the shape of the drilled hole or the cavity is not straight. Okay, straight sided. Okay, rather they are tapered. So to reduce the conicity, or we can call negative taper on your tool, higher static load on the tool can be provided. Okay, out of roundness in the holes, that is also major issue in this case of ultrasonic machining. And the tolerance, here I have written the tolerance that can be achieved or obtained by this process are near about plus minus 25 micron, and the upper limit of the depth of a drilled hole is normally that 51 mm. Okay, but in very special cases user have gone up to the 120 as a depth of penetration. Okay, but for this you require special kind of slurry pumping device so that slurry can go deeply inside that cavity. As well as again, what are the aspects or ratio that has to be obtained is its a range is given 4 dash to 1. Now aspect ratio means what? The ratio of depth to diameter. Okay, so these are the process capability of this ultrasonic machine. Let us discuss the applications of this process. So in this slide I have written the process applications. Now before going to process application, I will give time to write this process capability. So I will give 2 minutes to write this. Now let us discuss the process applications. Okay, so this is the last point. So this ultrasonic machining process can be applied for electrically uh, non-conductive as well as conductive material. Okay, that means your workpiece maybe or can be, you can call say conductive, electric conductive or non-conductive. Okay, so for both materials this process is used. Okay, or both materials can be machined using this process. Okay, because we are not making either tool or workpiece as a cathode or anode, because we are making tool or workpiece as anode and cathode in case of the EDM process. Okay, that we are going to see in next chapter. Again, this process it is a very good process for hard and fragile component. Okay, or the component which are made up of the hard and fragile material. Okay, fragile. So again, there is another way, very important capability of this process. There is a multiple holes. Okay, so it can be used. We can produce or multiple hole or multiple cavity can be machined at the same time using this process. Okay, again, it can be used as you can see in this figure also. Okay, which is I have shown in the slide. So so actually this is a tool and it's having the uh, more than one tool, and this is a shape that can be produced on the your workpiece. Here you can see. Okay, and you can see that there are the six bigger size holes. Okay, six of bigger size holes are there and six smaller size holes. Okay, you can see. So all these 12 holes have been produced at the same time using this particular tool, you can see. Okay, so this is a important process application. Again, the USM tool used to drill multiple holes simultaneously into the fragile glass disc. Also, again, processing of that silicon nitrate turbine blade. Okay, turbine blade which is made of the silicon nitrate. So the processing of that also possible by using this process. Okay, again, glass, ceramic, titanium, tungsten are the metals which can be machined by this process. You can see here I have written. Again, we have the that operations. Okay, like drilling, grinding, profiling, and the other kind of operation can be performed using this process. Again, now here I have given the one a very common example or common application of this ultrasonic machining. That is a dentist while drilling a hole in the tooth of patient uses this particular process. Okay, I repeat once again. Dentists are drilling the holes in the teeth. Okay, using this process. So this is a very interesting application of this ultrasonic machining. So ultrasonic machining is also used again in the conjunction with your electrochemical machining process, that is hybrid process. Okay, that means by combining hybrid process like this ultrasonic machining in okay, along with that electrochemical machining or electric charge machining or electrochemical grinding. Okay, so these are the applications. So now I will request all of you, please write down these applications. Okay, I will give the 2 minutes to write them. Write this. Now I request all of you, please put your roll number in chat box. Okay, and here we have completed our unit number 2. Okay, in next lecture we'll start our new unit, that is third unit. Okay, so I will write attendance, okay, from chat box. एकदाच रोल नंबर लिहा, सारखं लिहू नका. Okay, so thank you very much. You can leave this meeting.